All right, folks, we just want to welcome you back. Real quick, I just want to spend some time to review homework number 48, give you some solutions. I know that there were some problems with some of these acid-base chemical equations, and want to make sure that you guys understand what I'm looking for here. So we're just going to spend a little bit of time reviewing homework 48. You can watch as much of this as you want. You don't have to watch any of it. The point, I just want to make sure that I go over some of these problems with you guys since I am not here. So real quick, I just want to go over some of those formulas. And if we remember, the first formula we went over was that H plus times OH minus equals 1 times 10 to the negative 14th. All right, so that's one way we can figure out some of these problems. If you remember, pH equals negative log of your H plus concentration. All right, same thing with POH. Negative log of your OH. Okay, so hopefully remember those. If we remember the pH plus POH equals 14, and then if we want to go backwards, all right, remember if we want to go backwards, we want to know H plus is 10 to the negative pH. All right. So again, just make sure these formulas are going to be really, really important for you to understand and be able to use them properly when we look at these chemical formulas. All right. So you'll probably be given these. I'm not going to lie. I'll probably give you these formulas to use on your test just to make sure that you know how to do them. But expect the problems to be a little bit more difficult since I will be giving you the formulas. All right. So let's look at this problem here. It says determine the OH, H, POH, and pH of a 0.01 molar KOH solution. So let's see what we can do here. If we remember properly, we talked about strong acids and bases. And since this is a strong base, this is the same as 0.01 molar of our OH. Remember, when we put it into water, it's going to dissociate. It's going to break apart into its ions. It's going to break apart into 0.01 molar K and 0.01 molar OH. So we can safely say this from this KOH, that it's the exact same as the KOH molarity. So there's our OH. All right, so we can mark that off. We need to know H plus from this, and that's pretty simple as well, because if we remember, H times OH, concentration of H times the concentration of OH, equals 1 times 10 to the negative 14th. So we just need to plug it in and solve for H. You know, 1 times 10 to the negative 12th. All right, and that's a unit of concentration. So there's H plus. And to figure out POH, or POH, you just take negative log of OH. It's POH. So negative log 0.01, and we'll get our pH, and it's 2. Okay, so there's your POH. Now let's look at our pH. You can do this one of two ways. You can take the negative log of the H plus concentration, or if you remember, pH plus POH equals 14. So my pH is 2. Sorry, pH plus 2 equals 14, so my pH will equal 12. Okay? Again, it's just kind of one of those things where one thing leads to another. You just have to take your time and go through it. All of our information is here, but you just have to build on it one equation at a time. Figure out where to start, plug it in, and how can I solve for my unknowns. All right? It's really simple and really straightforward. Okay? What is the H plus of a solution containing a pH of 3.4? If we remember our formulas, we remember that we can work backwards by using 10 raised to the negative pH gives us H plus concentration, and which is what we want. So plug it in. 10 to the negative 3.4, that is a 3, equals H plus. Plug in and solve. Okay? So again, you just need to look for what you know, what you don't know, find the correct formula, plug it in, and solve for your unknown. A soft drink was put on the market with an H plus concentration of 1.4 times 10 to the negative fifth. What is its pH? Again, figuring out our formula, we need pH to solve. It's just negative log of H plus. So plug in and solve. All right. And if you want to know, is this an acid or base? pH is less than 7. It's an acid. Okay? Any questions on that? Well, guess you really can't answer me anyway, so we're moving on. What value of H corresponds to a pH of 8.3? Again, plug in and solve. Couple of things that we know here. We know that we can get our H plus concentration from pH, 10 to the negative pH. And that's it. Okay? Again, find the right formula, plug in, solve for your unknown. Find the H and OH of sauerkraut, which has a pH of 3.85. Again, similar to the last couple of problems that we've done, we know that H is equal to 10 raised to the negative pH. So 10 to the negative 3.85. And solve. So if we remember, H times OH equals 1 times 10 to the negative 14th. All right, we just need to plug it in there and solve. All right, and there's our answers right there. And there's our answers. So again, it's all about taking the steps, remembering what formulas to use, plugging it in, and solving for your unknown. All right? That's all I got for you today, guys. Any questions, let me know. We'll talk to you next time, all right?